So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir and today we will going to learn asymptotic notation of an algorithm. Now let's learn first what actually asymptotic means. Approaching to a value, or we can say to a certain limit. When I was calculating time complexity of an algorithm, I was actually saying the complexity of the algorithm is order of n or order of log n. Now, what actually this notation means, till what extent that a simple program may run. For example, if the program was if the number is even, then we will simply print it. But if the number is odd, then we will print it in the decreasing fashion. That is, if the number is 7, then we will print 7, 6, 5, 4, 3, 2, 1. Like that we will print it. Num I is greater than equals to 0, I minus minus, and we will print the I. So if the number is even, then we will simply print it. That's it. But if the number is odd, then this piece of code will run, and it will run for n number of times. So we can say the time complexity of this algorithm is order of n. But this is the first scenario. So we can say in the worst case, this program will run till n times. So to represent it, we used to give this notation. But not every time we need the worst case. Sometimes we need the best or average case as well. So due to this, we have some notations. There are total 5 asymptotic notations. They are big O, omega, theta, small o, and small omega. Now we will learn this term one by one. Now let's start with big O. You guys got some hint about what actually big O means, but let's read this definition first. F of n is equals to order of g of n if and only if f of n is less than c into g of n for all n where n is greater than n naught, such that there exists a two constant c and n naught. Now I know you guys didn't get this definition, but let me explain to you first. When we want the upper bound of a program, that at till what extent it will be run, then we use this notations order of n. So if this is the function, then this curve will be the upper bound of this function. So we can say that f of n is equals to order of g of n. This means f of n is a member of set of g of n. F of n is the member of set of g of n, where for all n that too starts with n naught. This is the n naught. From this point, the curve c into g of n start growing above f of n. Now, in the a priori analysis, I was saying if the complexity of a program, let's say, is n plus 7, then we will write as order of g of n. This means this function n plus 7 is member of set of n. Let's solve the first problem. Here f of n is n plus 5 and g of n is n. So according to the definition, f of n is equals to order of g of n when f of n is less than equals to c into g of n. Now let's put the values. The value of f of n is n plus 5 and the value of g of n is n, and we have to substitute c. We have to write c. Now to prove this condition, we have to take the help of c, which c is a constant and c should be greater than 0. But if we put c as 1, then it will not make any sense. It will be as it is. So let's put c is 2. N plus 5 is less than equals to 2 into n. Now we have to substitute some value of n. Now what actually n means? N is number of inputs. Now let's take n as 10 raised to 5. So now let's substitute it. 10 raised to 5 plus 5 less than equals to 2 into 10 raised to 5. Now this will become 100,005 is less than equals to 200,000. Now this is true. So we got the value of c, that is 2. Now let's find the value of n naught. Now since we got the value of c, let's find the value of n naught. N naught is a part of n only, but n naught should be start from 1. So let's put it in this equation. 1 plus 5 is less than equals to 2 into 1. False. Let's put n as 2. 2 plus 5 is less than equals to 2 into 2. Again false. Let's put n as 3. 3 plus 5 is less than equals to 2 into 3. This is 8 and this is 6. Again false. N as 4. 4 plus 5 is less than equals to 2 into 4. This is 9 and this is 8. Again false. Let's take n as 5. 5 plus 5 is less than equals to 2 into 5. Now this is true. So we got c as 2 and n naught as 5. So if c is 2 and if we start from n naught as 5, then f of n is a member of g of n. So we can say f of n is equals to order of g of n. It satisfies. Now let's take another example. Here f of n is n plus 5 and g of n is n minus 5. So let's put in the equation f of n is less than equals to c into g of n. F of n is n plus 5 c into n minus 5. Now c should be greater than 0 and n naught should be greater than equals to 1. Let's take c as 2 because if we put c as 1 then it won't make any sense. So let's put c as 2. n plus 5 is less than equals to 2 into n minus 5. This will become n plus 5 is less than 2n minus 10. Now let's put value of n as 10 raised to 5. So it will become 10 raised to 5 plus 5 less than equals to 2 into 10 raised to 5 minus 10. So this will become 100,005 is less than 1 4 times 9s and 0. So this is true. So we got the value of C as 2. Now let's find the value of n naught. Substituting n naught start from 1 equals to 1. We have to put n as 1 in this equation. So 1 plus 5 is less than 2 minus 10. This will be wrong. N as 2. 2 plus 5 is less than equals to 2 into 2 minus 10. Again false. Now I have calculated it, and when n is equals to 15, at this time this equation will satisfy. 15 plus 5 is less than equals to 2 into 15 minus 10. So this will become 20 is less than equals to 20. So when C is 2 and n naught is 15, f of n is equals to order of g of n. So f of n is a member of set of g of n. Let's solve the second problem. Now here f of n is n square and g of n is n square plus n plus 5. So let's substitute in the equation. F of n is less than equals to c into g of n. So n square is less than equals to c into n square plus n plus 5. Now if we observe this equation, it already satisfies, because here it is a single n square term, but here n square is associated with n plus 5. So the right hand side is bigger than left hand side. So when c equals to 1, this condition satisfied. Therefore n naught will be equals to 1 only. So f of n is the member of set of g of n. Now let's solve this next problem. Here f of n is n square and g of n is n. Now substituting the value in equation, f of n is less than c into g of n. N square is less than equals to c into n. Now when c equals to 2, it will become n square is less than 2 into n. Now let's put some value of n. So to make this condition true, let's take n as 1. It will become 1 is less than equals to 2. Yes, it is 2. Let's take n as 2 again. 4 is less than 2 into 2, which will be 4 only. Again true. But let's take n as 3 again. 3. 9 is less than equals to 2 into 3, which will be 6. Here it is false. So this is not possible because to satisfy this condition that n square is less than c into n, here there is a difference of function, and we know that is a constant which greater than 0. So it can't be a function. If we want to satisfy this condition, we have to put as n. At that time this condition will satisfy, but we can't put n as a function. We have to put c as constant. So here in this case f of n is not order of g of n. F of n is not a member of a set g of n. So in this way we find whether f of n is a member of g of n or not. So if someone says n plus 5 is order of n, then with this method we can prove it that f n plus 5 is a member of n or not. So in the next lecture we will going to learn omega notation. Thank you.